Okay, so C1 is called Cartesian plane, and Cartesian plane is a fancy way of saying coordinate grid. That's all it is, okay? So this is something you already know. It's got an X, Y axis, that kind of thing. A quick review of, because hopefully you remember most of this, the quadrants start in the top right corner, and then they go counterclockwise. So this top right quadrant is quadrant 1, quadrant 2, quadrant 3, quadrant 4. The horizontal line is your x-axis. The vertical line is your y-axis. And then where they cross is called the origin. So literally as simple as plot this point and identify the quadrant. Obviously, you want to, if it lies in one of the four corners, you would identify that as its quadrant. If a point lies on the vertical axis, then it's not on a quadrant, right? We would say it lies on the y-axis. And if it lies on the horizontal line, then we would say it lies on the x-axis. So even though the wording says which quadrant, the axes also count as answers, and the origin if it was 0, 0. All right, so example 1, literally graph and label these points. This is your opportunity to feel super smart. Remember, the x goes right and left, the y goes up and down. Go ahead and plot and label those points. And then right next to the letter, write which quadrant they fall in. You can just give me the number or the axis. All right, so this is what we should have gotten. A is to the right 2 up 3. B to the left 2 up 3. C to the right 2/3 down 3. D, don't move left or right or I'll just go up 3. E to the left 3. And then F right there at the origin. So which quadrant would you say A lies in? Quadrant 1. You can either use Roman numerals, you can use the number 1, I don't care. Okay? B lies where? Quadrant 2. C lies? Quadrant 4. D lies on the y-axis. Good. E, x-axis, and F, origin. Good. Sadly, not quiz questions, but obviously if we don't understand that, then moving forward, everything gets rough. Okay? All right, example 2. This is how you will see that applied, and this could be a quiz question, okay? Determine which quadrant or quadrants satisfy the given information. So number 1 says x is greater than 0 and y is less than 0. So break it apart. Where on your Cartesian plane or coordinate grid is x greater than 0? On the whole right-hand side, quadrants 1 and 4, right? Where is y less than 0? Quadrants 3 and 4 underneath. So if it had said or x is greater than 0 or y is less than 0, then it would be all 3 of those. But it says and, which means the only answer is where they overlap, or quadrant 4. Two says x times y is less than 0. So we're talking about the product of two numbers. And less than 0 is what kind of number? A negative. So how does a product result in a negative number? One of them has to be negative, right? If they're both positive, it's positive. If they're both negative, it's negative. But if one is negative, then that product would be negative. So in which quadrants? In the top right, they're both positive, right? In the top left or quadrant 2, the x is negative, the y is positive. In the third quadrant, they are both negative. And in the fourth quadrant, the x is positive and the y is negative. So the answer to number 2 would be what? 2 and 4. Good. Quadrant 2 and quadrant 4. Questions so far? All right. Slide 3 or 4, whatever we're on, or 5, sorry, is called a scatter plot. So your pre-calc book calls them scatter plots. We will learn to use these in something called a stat plot on your calculator when we get into the AP content, okay? But it is just a graph. In this example, you've got your x-axis is your hours of study, and your y-axis is your test scores. And then all those little dots are the results of data. So it looks like at about 3 hours, the average test score was about 60. At 4 hours, it was a 51. And then it kept going up for the general pattern, okay? So if I ask, like, what's the general pattern here? This has a positive slope because as it moves to the right, the y moves up, okay? So I could say something like this has a positive correlation. When it asks you, and your AP test will, like, ask you about the data, what does it tell you about the data? And you would say, as the hours of study increase, the test scores increase. And you could say the words like in general because it's not guaranteed, right? Some of those went up and then came back down. But you're looking at the overall pattern. We're also going to talk about what are called regression models. And a regression model is which type of graph would be the best approximation of the shape of this data. And in this case, it would be linear. Like you look at that, a line for the most part fits at it, okay? There are going to be times in which it goes up and comes back down again, in which a parabola would make that shape, and so it would be quadratic, okay? But that is, like, when we get into the AP content, we're going to start talking about that kind of stuff. All right, example 3. Use the info from the given table to graph the scatter plot. Remember, you have to label both your x and y axis. And then you can set up your intervals however you want. I'm not going to tell you how to do it, but be consistent. Go ahead and set that up. Okay, again, yours doesn't have to look exactly like mine because you could have spaced your y-axis differently. Okay, I went by 20s. You could have literally jumped a good amount and then started to go by 10s. Whatever it is you want to do, as long as you're consistent on that left side. So what do we notice about the general trend here? It's decreasing, right? So in words, we would say what?
As the chapters increase, the class test average decreases.
Perfect. As the chapter increases, the test average decreases. Okay? Yep.
Do the chapters have to be on the x-axis, or could it be the averages?
That's a good question. Because they gave it to you in teach heart form, I would always make the x the left and the right the y's. If you just had data, not necessarily. You could switch that. But if it gives you it in that chart form, you want to do that.
Okay.
Other questions on scatter plots / stat plots, because they'll use that term. All right, now we get into two formulas, okay, that if we need to remember. So I'll tell you this right now. There is no reference sheet on your AP exam. So, SAT gives you a little box with like all that stuff. It doesn't exist on the AP exam. So as the year goes, I would recommend you build a formula sheet of all the things you're supposed to know. We will review it again as we get closer, but I would recommend you start to build it for yourself. And the first two are the distance formula and the midpoint formula. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And the midpoint, x1 plus x2 over 2, y1 plus y2 over 2. Now, there's not a whole lot of coordinate stuff on your AP exam, but standardized tests also assume you know these things. So we have the challenge of doing both, preparing you for an SAT, ACT, and then also preparing you for an AP exam, which covered different content. The distance is going to result in a single number. If it is a square root, whatever that number is, it has to be simplified. So you will never leave something as the square root of 25. You'll always make that 5. And you would never leave something as the square root of 20. You would make that 2 root 5. So every square root you write has to be simplified. Whether you use the, the factor tree, whatever it is that helps you, you have to remember to simplify your square roots. And then your midpoints are coordinate points, an x, comma, a y. And these you can, if they're not whole numbers, you can choose. Leave them as fractions. I would say that's the easiest thing to do. Leave them as simplified but improper if they're improper. You can also leave these as decimals as long as they terminate. All right, example 4 says find the distance and the midpoint using the given point. So if I look at A, and it doesn't matter which one we make the 1s and the 2s as long as within the parentheses they are both the same number. If this is x1, this could be y1, this could be x2 and y2. And the distance, square root of 4 minus a negative 3 becomes plus 3 squared plus 2 minus 2 squared. I get the square root of 7 squared plus 0 squared, square root of 49, which goes back to 7. And then the midpoint, we add the 2 x's, divide by 2, add the 2 y's, divide by 2. And I get 1/2, 4/2, which is going to simplify to 1/2 and 2. All right, you do B. All right, so for the distance, you should have gotten square root 10. You'll leave it like that, keep it exact. And then your midpoint, negative 3/2 and 7/2. Good morning. All right, so this is how, one of the ways that we'll use some of those things, and that these are called coordinate problems. So they're going to give you the coordinates to some points, and they're going to ask you questions about the shape that it makes. So you could see this with triangles, which is like this. It says you're going to verify the type of a polygon, specifically in this case if it's a triangle. So they'll give you 3 coordinate points. Just plotting them on a coordinate grid is not enough information to justify the shapes of them, especially something that involves the lengths of the sides. So if it's a right triangle, you're going to verify that it's a right triangle by showing that the side lengths would be good in the Pythagorean theorem, which is a squared plus b squared equals c squared. If it's an isosceles triangle, you're going to show that 2 sides have the same length. And if it's an equilateral triangle, you're going to verify that all 3 sides are the same. A right triangle, outside of, if it didn't ask for the lengths of the sides, which your quiz will, so you'll use that this way. The other way you can prove something's a right triangle is by showing that 2 of the sides are perpendicular. So how would I know 2 sides are perpendicular? How do you know there's a right angle there? Without having a protractor, let's say. How would you know? What's true about the slopes of 2 perpendicular lines?
They're opposite.
They're opposite and reciprocal. So if you found the slopes of those lines, which is in, like literally that's in section 1.1. We're going to go back over it. But if you found the slopes of those lines, you could also show that they are perpendicular, which would prove it's a right triangle. But these questions are going to ask you to use the distance formula to find the lengths of the sides of the triangle and then classify it. So you might as well do this method, which is a squared plus b squared equals c squared. Okay? All right, so a question could look like this. Use the coordinates A, and that is a 6. This is, every year I forget to change this font. These are 6s, okay? That is 6, 3, B is 6, 0, and C is 2, 0. To show that ABC is a right triangle. Now, again, I want to say it again. Just drawing this out is not enough information, okay? I would recommend at least sketching it so that it gives you an idea of what you're looking at. And if that's the case, I would say, okay, 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, that's A. 6, 0 is B. And 2, 0 is C. And here's the triangle I'm trying to prove is a right triangle. First of all, it should appear to be right. Otherwise, the whole thing is wrong. And by doing this, we can realize that there are 2 sides that are either horizontal or vertical. Those sides, you can simply count the distance. You don't have to do the distance for those sides. So for side BA, we went from 0 to 3. That side is 3. For side CB, you went from 2 to 6. That side length is 4. And then AC, obviously we cannot count that way, so we're going to find the length of AC using the distance formula. Square root of A and C. So 2 minus 6 squared plus 0 minus 3 squared. 16 plus 9, square root 25, which is 5. If you remember your triples, then you remember that 3, 4, 5 is a triple. But the point here is to verify. So when it says show, we actually have to back it with the work. So we have to show that AB squared plus BC squared equals AC squared. How do I know which one to put by itself? How did I know AC had to go here? It has to be the hypotenuse, right? And by looking at this, I'm looking at the longest side, or I'm looking at the side that's opposite the right angle. So if AB is 3, and BC is 4, and AC is 5, 9 plus 16 equals 25, and 25 equals 25. So if it says show it's a right triangle, it's already telling you it is a right triangle. You just have to back it with the work. You're going to find the lengths. You're going to show that A squared plus B squared equals C squared. If it said show that it's an isosceles triangle, you just got to find two lengths that are the same. And the benefit of graphing that ahead of time is to look, because it might be obvious which two sides are closer in length. If it said show that it's an equilateral, you'd find the length of all three sides and show that they are equal. The other type of question might be classify this triangle. So it's not going to tell you which one of those three options. It's going to say here are the coordinates for 3 points. Classify the triangle as right, equilateral, isosceles, or none of these. And you'll find the lengths of all three sides, and you'll see if it is one of those. Okay? So there's two types of questions you'll see with this. Questions so far? Okay. Last thing in this section is circles. This is the standard form of a circle. X minus h squared plus y minus k squared equals r squared. The center is your hk and the radius is your r. So 3 equations / formulas you need to know for this section. Midpoint, distance, standard form of a circle. So if it gives you information about a circle and it says write the standard form, it will eventually look something like this: x plus or minus a number squared plus y plus or minus a number squared equals a number. So those are the spots that you will fill in. You'll fill back in the h, k, and the r. You could get given an equation and it could ask you about that circle. So it could say, here's standard form of an equation. What is the center? So when we pull those values out, we change the sign and square root the r. Or it could give you the center and the radius, and you have to plug it into the equation. Again, we change the signs on the h and the k, and we would square the r. Or it could say, here's the center and the side and the coordinate point, or here's the endpoints of the diameter, which is the example we're going to see in a second. All right, so example 6 says, find the equation of a circle that passes through, totally ignore these. Are they on yours? No. Yeah. I feel like I remembered I took them off, but not my own. Okay, find the equation of the circle that passes through 3, 4 with a center of -2, 1. So if I've got a circle, right? Well, let me draw the coordinate grid first. You don't have to do this, but I'm giving you a visual. 1, 2, 3, 1, 2, 3, 4. Center, -2, 1. That means my circle does something like this, right? Terrible circle. You can do it better on Notability. Explain Everything doesn't have that tool. Okay. If I wanted to find the equation of the circle, and the standard form is x minus h squared plus y minus k squared equals r squared, what pieces of information do I need to know in order to plug it into that standard form? I need to know r, and I need to know h and k. So what is hk? That's the center, right, which is negative 2, 1. I already know that part. What I wasn't given is the radius. How could I find it? Nothing. The distance from the center to that coordinate point, right? So literally the distance from here to here would represent r. So I'm going to use these 2 points as the distance. Yeah. Yeah, good. We're going to do it both ways. So you can find the distance. So I can say the square root of negative 2 minus 3 squared plus 1 minus 4 squared. Square root of negative 5 squared, negative 3 squared, 25, 9, square root 34. You with me so far? Yeah. Now that's the radius, right? But what do I do to the radius when I put it into the equation? I square it. So what's the square of the square root of 34? Just 34. So when I plug it back in, I put the h in. This is negative 2. I put the k in. This is 1. And I square the 34, or the square root of 34, which is just 34. And I would get x minus a negative 2 becomes plus 2 squared plus y minus 1 squared equals 34. Yep.
How is it just 34? Like, what happens when it's...
The actual radius is the square root of 34, but in your equation, that r is squared. So we would square the square root of 34. Does that make sense? All right, so that is one way to do it, and it totally works. The other way to do it is that if this is a point that's on the circle, this is an xy, and any xy that is on that circle can be plugged into this equation as xy. So then from the beginning, without having to do the distance formula, I have the h, I have the k, I have the x, I have the y. The only thing you're missing is the r squared. So if I were to plug that in, then I would get, and the order is important, x has to come first, then h. So I'd get 3 minus a negative 2, which becomes plus 2, squared, plus 4 minus 1 squared equals r squared. And I get 5 squared, and 3 squared, and I get 25, and I get 34 is r squared. Now if it asked you for r, you'd have to square root it, but the equation just asked for r squared, so I could leave it alone. 2 different ways to do it, both are fine. Questions on that one? I'm going to add to this real fast because you're going to see it in the homework, and you could see it on your quiz. And that is, what if I had said the end points of the diameter are these coordinate points. So if you want to add a slide in, how does that change things? Do you have your center this time? No, you don't have the center, okay? But you have 2 endpoints of a diameter, right? So if 1, negative 1, 2 is one endpoint, 1, 2, 3, 4, 1, 2, 3, 4, 5. And that's the other endpoint. That means my circle does something like this. How could I find the center? Yeah, Richard. Good. Midpoint between those 2. So the midpoint is the center. So I would do negative 1 plus 4 divided by 2. And I would do 2 plus 5 divided by 2. And I get 3 halves and 7 halves as my h and my k. Can you have fractions as h and k? Definitely. You can make them decimals if you want to. And if I want to check like visually, that's 1.5 and 3.5, which is about where we are on that little diagram. Now, what else do I need for my standard form? We've got the HK. What are we missing? The R. What's one way to find it? The distance from what to what? So one option is distance from the center we just found to either of those endpoints, right? And that answer will give me the radius. That's one option. What's another option? I can plug in this as my H and my K, and then either of these points as my X and my Y, and solve for R. There's one other option, and it's the one I would say to avoid. And that is use these points, find the distance all the way across, but what does that represent? The diameter. So what would I have to do to it to get to the radius? Cut it in half. And that gets messy when there's square roots. Like people just make mistakes when you're taking a square root and you're cutting it in half, so I say avoid that, okay? My advice is to plug in this time. Especially if there's fractions and then you're dealing with square roots that have fractions, interesting things happen. So I would say in a case like this, I find the center and then I plug in the center and one of those points. You're still going to have fractions. You can't avoid it. But it's not, I think less mistakes happen there than when people try to do the worst is the diameter and cut it in half. Because people forget with the square roots, like when you simplify a square root, do I take that number out now? Do I cut it in half? Like that's when mistakes get made. So if I was to do that, let's just say, and I would say, as smart as you guys are, negatives are like people's kryptonite. Avoid it if you can. So if there's a coordinate point that are both positive, I'm going to use that one, the 4 and the 5. And I would say 4 minus 3/2 squared plus 5 minus 7/2 squared equals my R squared. So then 4 becomes 8/2, and this is 5/2 squared. 5 becomes 10/2, and this becomes 3/2 squared. 5/2 squared is 25/4. 3/2 squared, 9/4. And I get 34/4 is R squared. Now, if it asks for R, I have to square root it, and it end up being the square root of 34/2, because you have to square root both. But this question wasn't asking for the R. It's asking for the equation, so I will leave it as R squared. Leave it alone. You don't even have to worry about square rooting it. And I'd get X minus 3/2 squared plus Y minus 7/2 squared equals 34/4. Questions? Yeah.
So when you write out the equation, you don't have to fill out the X and Y.
Nope, you want to leave X and Y as X and Y. Good question. Otherwise it actually would be wrong. Because you shouldn't be picking just one specific point. Yeah, you'll leave the X and Y as the X and Y.
Do you want us to simplify the R squared?
Yeah, oh, I should have, yes. This should be 17/2. Thank you. Yes. Questions? If it had asked for R, I would have left it as 4 because otherwise then you have to rationalize. But when you are writing it as your answer, you want to simplify. All right, so tonight's homework is a PDF. Like the next two are PDFs because they come from that prerequisite chapter. And then we will get into WebAssign next week. But for the next two, they are PDFs. Please show your work. That's the only way that you really get points deducted on PDF homework, I would say. And then tomorrow, the solutions will get posted after 8:05 a.m. We can also I'll answer questions in class, but make sure you have your graphing calculators with you tomorrow because it's something we're going to spend a chunk of time on tomorrow, okay?